Go. Hello. Year 11 chemistry. As we're going to do the new topics, this term. This is the last unit, kind of last area before we have the exam, the ME exam, and that is all about carbon. Because I'm not sure, I've been thinking about the term two is not very easy to run as the class a bit hard to get it together, and yeah, it's kind of a bit slower than I think. So I'll kind of speed up the whole process by making a bit more videos. Let's see. Hopefully it works a bit better now. Um, Chemistry Unit 1, the final area. This particular area is all about organic chemistry. So most of you would familiar with organic chemistry with carbon. As organic chemistry or has another name, we call them carbon chemistry. And in terms of organic chemistry, linked to one of the very big topics that we've learned so far, which is called covalent compound. Covalent compound means that we have the bonding that between two non-metals atoms, and those atoms definitely different types of environment, different types of elements. When you have two different types of elements joined together, then what do we have? We have a sharing electrons conditions. As we all have carbons, I'll use carbon as an example. Since carbon has 4 valence electrons, you would say when carbon try to join with hydrogens, as hydrogen has 1 electrons, when they share 1 electrons, you will find that there will be a single bond in between each other. So 1 carbon over 4 single electrons. So therefore, you will see that the carbon would be able to join to 4 hydrogens as a single bond, right? And when you try to look at carbon with oxygen, as carbon has 4 valence electrons, and each of the oxygens has 6. Since covalent compounds means they need to share the electrons, and being fair, for carbon and oxygens, each one of them need to share the electrons and put it in between them. And when those two joined together as a bonding, 2 electrons joined together as a bonding, you will form a double bond between oxygens. As oxygen has 6 electrons, you will see in particular there's 1 carbon will join to 2 oxygens. We form 2 double bonds. Then at certain situations, you will find that carbon can form triple bond as well, which is like nitrogen. Nitrogen has 1, 2, 3, 4, 5 bonding, and carbon has 1, 2, 3, 4 bonding. In these situations, you'll find that carbon will need to join to the nitrogen with a triple bond. However, there's 1 single electron running around. For most of the situations, carbon will grab a hydrogen next to it to form octets. So if we find 1 triple bond on one side for carbon, most of the time we will find a single bond on the other side to make it the octets. So that's 3 simple examples to show you that all carbons, when they form bonding, they will be covalent compound. They will be sharing the electrons. They need to form octets. So hopefully you will realize when you try to do covalent compound, they share the electrons and achieve octets. Achieve octets is very important for carbon chemistry. As carbon can form 4 bonds, it has 4 electrons. So if you put carbon next to each other, it allows them to have a carbon-carbon single bond, or a carbon-carbon double bond, or a carbon-carbon triple bond. So it's just like try to try to make sense of carbon, and carbon is a very high variety. It can form all different types of bonding, single, double, or triples. If you try to put all the carbon next to each other, and you will find carbon has one properties that allow them, and for forming lots of bonding, a carbon has a capacity to form a very long molecules. In theory, carbon can form just unlimited, like infinity. So the lots of this keep going on and on and on and on. If you allow the situations, keep going. That one of and that long molecules is very important for us to do organic chemistry, and we spend maybe a few more weeks later on to look at these long molecules. And these long molecules, we do have another name, call them polymer. And polymer has and that would be very important for us to look at is intermolecular force, how those forces interact with each other later on this course. So now we have an introduction of about covalent carbon bonding, single bond, double bond, and triple bond. Let's move on into one particular group that we study a lot in carbon chemistry. We call them hydrocarbons or hydrogen carbon. Hydrocarbon, hydrogen carbon. Molecules, it basically means that you will see in this particular group, you only have two types of elements in there. One is carbon, the other one is hydrogen. And just looking at those two, you will think, oh, that would be a simple situations. But in reality, there's a way more than way more than what we think. There's a lots of well, I could say the countless possibilities if you just join those two together, because you can try to think of if there's only one carbon with 4 single bonds, you'll find that we have CH4. But if you try to see there's a 2 carbon next to each other, they're all single bond, I would be able to join extend it into 2 carbons and 6 hydrogens. If you continue doing this with another carbon there, I have 3 carbons with 1, 2, 3, 4, 5, 6, 7, 8 carbon. Just do a little bit mess. Every single time, if you have 1 carbon to begin with, 4 hydrogens. If you have 2 carbon, you have 6 hydrogens. 3 carbon, you have 8 hydrogens. Every single time when you move by up from 1 carbon to another carbon, you add another 2 hydrogens. Can you see that particular pattern? Every single time you add 1 carbon on top, and you will be having another 2 hydrogens. For every single, if you learn about maths, this is a linear relationship in terms of number of carbons and number of hydrogens. And every linear equation, you can try to use a formula to represent them. And this particular situation, they're all single bonds. When there's all single bonds, all single covalent bonds there, you will find the formula for that is called CnH2n plus 2. So every single time, the number of hydrogen is 2 times the number of carbon plus 2. So if you're talking about a carbon with, how many of them? A carbon with, let's say, 20 of them. What would be the number of hydrogen? The number of hydrogen would be 2 times 20 plus 2. You will find the one that with 20 carbon long molecules joined together would have 44 hydrogens, 2n plus 2. Wherever we have 2n plus 2, then we have a particular name to delegate to this particular group, and this group is called alkane. When you say alkane, it means that the all single bond, and it follows with the formula, which is 2CN H2N plus 2. No matter you try to write this formula or try to call them alkane, exactly the same. So there's no difference. The way that we why do we try to learn all this? Because as the carbon numbers increasing, we can see the different properties and the similarities, and there's some differences. And to begin with, understanding organic compound, like this simple organic compound, help us to understand what life is about. Organic means life, and we have organic chemistry to study everything happening in life. Alkane is the basic building blocks for most of our life. It consists of carbon and hydrogens. And the first thing to do organic chemistry is try to do the nomenclature, which is the naming system. How do we name all these alkane? Alkanes naming based on the number of carbons. You encounter something like CO2, you know that is a carbon dioxide, or you encounter like C3 blah blah blah. In covalent compounds, you try to say tricarbon tetraoxide, stuff like that. But when you get down to alkane, we have another particular systems, and that system related to number of carbons. If we have one carbon, we call them meth. If we have two carbons, we call them eth. If we have three carbons, we call them pro. And so on. I just try to do it as quick as possible. Bear with me with my handwriting, because trying to do handwriting and do the video is a bit it's not that easy, especially when you just look at the screen and try to write on the writing board there. The first 6 of them you need to memorize by the end of this video. It's not hard to do. 1 carbon is meth, 2 carbon is eth, 3 carbon is pro, 4 carbon is butyl, 5 carbon is pent, 6 carbon is hex. It's a little bit different when you try to look at covalent compounds. When you're looking at covalent bonding, the 1 carbon, we call the one thing. If you only have 1, we call it mono. If you have 2, we call them di. If you have 3, we call them tri. If you have 4, we call them tetra. If we have 5, we come to the same thing, pent and hex. So 5 and 6 pretty much the same, but the first 4 make a little bit different from each other. I don't know why, but there may be a reason when you try to see meth, eth, pro, build, it's just letting you saying there is an organic chemistry, not really a covalent side. And we try to say for those 4, we will use it later on, but not the major use. There will be some either side naming system. We're going to use di and tri and tetra. So you'll see very soon. So when you try to name alkane, there's a funny things that we need to do is carbon can form lots of structure. If we have carbon with 2 of them, you only have 1 options, which is carbon-carbon, join them together. If you talk about 3 carbons, it's exactly the same, because no matter what you do with the carbons, like this one pointing up, you're still seeing this is exactly the same molecules. You're just using, try to highlight the last part, this one, because it's a single bond there, and a single bond is something that you can twist. If you build a model, I will try to build a model in class. So with 3 carbons joined next to each other, single bond, you can twist the bonding, basically twisting 90 degrees up, 90 degrees down. You will still be behaving exactly the same as the same molecules. As this is the 3 carbons, what would be the name of this particular 3 carbon molecules? 3 carbon means pro. And because it is alkane that we are looking at, and we call them propane. The same thing for the first one and the second one here, we also call them propane. Nothing difference between with one another, because this one is just like banded over, this one just goes straight down. They belong exactly the same compound, and because they are the same, we call them propane for each other. However, if you try to look at 4 carbon next to each other, and there would be one thing that we can do. As it is 4 carbons, we call them 1, 2, 3, 4. 4 carbon use but, B-U-T, and it's alkane, so we call them butane. Since it's butane, so you can think about, what if I try to bend those 2 over like this way? Just clean it, just give myself a bit more room. Do this again. What if I try to join this 1, 2, 3, 4 with one another like this? So just imagine like every single bond I'm trying to attach on it is a little hydrogens. As a little hydrogen there, it just saves some of my time. I try not to draw it out. Just assume they're all in there. Because this one is going all straight down, nothing really we call them a strict molecules. And the second one is also a strict molecule because I just try to bend the top one, the first one, and the last one. As this one just get bent over, I'm still be able to call them a butane. What if I change a little bit? There's a few things that I can do with this. What if I try to place 1 carbon right there at the top? In order to change from the strict line to the third structure that was there, I cannot just bend over it. I have to break some bonding. I have to break at least 1 bond. So you try to see a little bit. Let's zoom in a bit. You have to chop one of the end off and try to move it to join to the second one. If you don't do that, there's no way that you're just bending over the strict one and go into the second one. When we have these situations and we know that this more like a strict lined molecules, it come into that one with 1 strict line but consists of 1 side branches. That one is basically, it's not belongs to the main trunk, you add on top of the main trunk. Since that happens, in organic chemistry, we find that as if you're getting longer and longer, and you may build a lot of either side branches, and all the molecules behave different from each other. When they behave different from each other, if using the same name for them, it doesn't really make sense to us. So even though they all have 4 carbons and 10 hydrogens, the first one and the second one, we can say that they're identical to each other, name them exactly the same, they're fine. If you try to name the third one exactly the same name, it doesn't make sense to us, behave completely different from each other. Even though we have C4H10, we have to call them something else. How do we call those structures with exactly the same formula? We call them isomers. Isomers means you have the same formula but different structure. When you have different structure, given different names, and this is called methyl propane. Why is called them methyl propane? Just try to look at the one that I highlight in red. We call this main trunk. Wherever we call this main trunk, we put that as the base at the end of it, the trunk, and the top over there is the side branches. The side branches right there. You can try to say, okay, why can't we say this methane propane? Because methane means that is what is the family do they belongs to? It belongs to alkane. It needs to dedicate to the longest carbon chain, and then the one that in front of it is a bit less important. And that less important is just like it's little side branches from the main trunk, and and the scientists decided, okay, if that's the one, try to give them like an adjective, put a YL instead of LY, put YL. I'm not sure why it's that. And then it's methyl propane. For looking at this particular system, you can play around with a lot of different way. 5 carbons. 1, 2, 3, 4, 5. 5 carbons. We can have the very first one, we call them pentane. And this is 5 carbons, a strict line. There's no side branches. Or you can try to put them as 4 of them, put 1 side branches at the top. We call this butane. 1 side branches, methyl. Would it be able to try something else, which is, what if I put 3 things there? 1 side branches at the top, 1 side branches down there. Then I call this propane. I have 2 methyl, 1 at the top, 1 below. Therefore, we call them dimethyl propane. Can you see that? Where the dyes come from this time? We still use the covalent compound system, but only when we out of options. When we're out of option, we need to mention about these 2 side branches, and how can we name it? If we just say it's double methyl, it's a bit too difficult. Dimethyl means 2 side branches. 1 side branches here, you have 4 carbons, is butane. 1 side branches at the top, methyl butane. Then we have the longest carbon chain for the first situation. We've got that is called propane. We've got 1 side branches, 2 side branches. 1, 2. We call them dimethyl propane. You have seen this is like 1 isomers. Isomers means all 3 of them belongs to C5H12. C5H12, C5H12. If you count the carbon next to them, it's always 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 5, 12. If you count that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. If you count the last one too, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Every single carbon has 4 single bonds, and that is alkane. And 12 and 12 and 12, and they all have different names. When you have different names with the same formula, they are isomers to each other, more like a brothers to each other, like they are brothers. And in chemical, we don't call them brothers, we just call them isomers. So when we have isomers, we have the same same chemical formula. But we have different names. The different names implied different structure. They come from the same family. They all same family of alkane. They are brothers to each other. We call them isomers. And each brothers has different names. And they may behave similar, but may behave different from each other. Right? So that's kind of the ideas about naming one of the most important part of what we call hydrocarbon, the hydrogen carbon. There will be more to come, but like that, at least I can show you this is the initial class, helping you to understand the simple number of way to name compounds. Okay, I'll stop here. because like it's just letting you know to do a few things. There's another videos coming up. It's about more naming systems and more complicated naming. So that's hopefully that's help you out from now on. Okay, thank you.